What's up, guys? We are going to continue here with chapter 4. So today we're going to be working on writing a function rule out of a word problem. So make sure that you're pausing and taking good notes. You'll want to have good notes and good examples for this. This is something in the past that's proven kind of difficult for students. So we want to make sure that you're good on it. All right, so let's start with this first one. It says you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? Okay, so this is going to kind of be our method of working through these writing a function rule things, where we're going to relate and then we'll define and then we'll write our function rule. So relating is just taking this and simplifying it. All right, so how do we want to say this? Well, we're going to say the temperature is, okay, so there gives me something. So I'm going to say the temperature, and I'm going to abbreviate here. The temperature is 40 degrees more than 1/4. Okay, so is 40 more than 1/4 of the number of chirps per minute. More than 1/4 of number of chirps. And we'll leave it with that. That's enough information. Okay, so that's just relating. That's just kind of taking this and getting rid of some of the words. So that's what I have for that. Next thing is to define this. So define means I need to assign variables. I don't know what the temperature is. I'm writing an input-output rule, a function rule. So I'm going to say the temperature is, I'm going to call that T. That's my variable. And then I'm going to say the number of chirps, I'm going to call N. So this is literally just defining the variable. I don't define this because it's already defined. I don't define this. But I would define the number of chirps is N. The next thing is to take this in combination with this and then write out a rule. So the temperature, which I'm going to call T, is, anytime you see is, it's almost always the equal sign, is 40 more than, so that means 40 plus 1/4. And then if it says of is almost always multiplication, the number of chirps, which is N. So I'm going to put 1/4 N. So T equals 40 plus 1/4 N. This is my function rule. This is just taking the words out and slowly working my way down to a function rule. That's our big focus today. All right, so go ahead and pause and you try this. The answer will be up in 3, 2, 1. So here I have the answer. I would have waste, W is waste, 420 times the number of months plus the 50,000 tons that's already in there. If you did not get that, go back and think about it some more. All right, this is your truth of the day. He went to the moon and he took 5 photos. This is our generation. Went to the bathroom, took 37 photos. Oh my goodness, we have a sick, sad world that we're living in. Writing and evaluating a function rule. It says a concert seating plan is shown below. That's going to be on the next slide. Reserved seating is sold out. Total revenue from ticket sales will depend on the number of general seating tickets sold. Write a function rule to represent this situation. What is the maximum total revenue? All right, so we're going to go through this again. It says that you may need to go back on the video, but the reserved seating is sold out. So I'm going to make a note here. Sold out, no more. And then I need to know how much general seating I could sell. Okay, so this one we're going to have to think a little bit. The relate is total revenue is the general seating revenue plus reserved seating revenue. And then I need to identify a couple variables. So I'll say the total revenue is represented by a capital R. And then I'm going to say that N, so total revenue is R. And then I'm going to say that N is the number of tickets sold. General tickets sold. And so we'll stop with that right there. Now I need to erase this so that I have more room, so you'll want to make sure that you go ahead and pause and get this down. So now I'm going to write out the function, and you should have this in your notebook. I don't have room for it. So first thing is the revenue is going to equal the general seating, which is $10 per seat. We don't know what that value is, so we're going to say 10 times N for the number of seats that are sold. And then we have to add what we got for the reserved seating. Well, first thing that we have to do for that is to figure out how many seats were sold. So I have 10 times 12. And then to figure out the total amount made, I have to multiply that value by 25. Now, this isn't the only way you could have done this. It's just the way that I would have. So we have our function here. The revenue is going to be 10 times whatever number of seats they sell here, plus the revenue that's already made from the reserved seating. The one thing I have to do here is simplify this. So I'm going to have R equals 10N, and then I multiply those values together, and I end up getting 3,000. All right, so there is my function rule. And I believe that's all that we were asked to do. Let me go back here. What is the maximum possible revenue? The maximum possible revenue is going to be finding out, well, how many seats can I sell here? So 30 times 16 is 480. So that's the most tickets that I could sell for this. So in order to find out the total revenue max, I take 480 and I put it in here. So I'd have R equals 10 times 480 plus 3,000, and then simplify all this out, and you end up finding out the revenue is going to be $7,800 is the max revenue. Not a bad payday for a one-night show. So that's how you'd work that out. There's a lot to that. Okay, so this is really, really important. Make sure that you are paying attention to that. All right, writing a nonlinear function rule. So this is a little bit tricky as well. Make sure that you are taking good notes for this. It says write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9? Okay, so the first thing that we need to do here is think about the area of a rectangle, which is equal to length times width. Function rule for the area of a rectangle whose length is 5 feet more than its width. So the length, I also know, is the width plus 5. Okay, so I could substitute this in, and instead of length, I would write this. So the area of a new rectangle is going to be the width plus 5 times W. This is the length. I just replaced it. I took this value and I plugged it in there. That's what this is. Length times width. I don't know what that is right there. So let me erase that. All right, so there's my new formula. I would need to go ahead and go through and simplify this. This is an application of the distributive property. So the area is going to be the width squared plus 5W. Here is my function for the area of a rectangle. All right, there's my new function. And then you're asked, well, what is the area for a width that is 9? Well, then I take 9 and just substitute it in here. So I have area equals 9 squared plus 5 times 9, which means area is equal to 81 plus 45, and 81 plus 45 is 126. All right, so that is the area for that. You could simplify this out, write a function rule that represents this particular situation, and that's what you'd get. Let's take a look at, I think it's a U try. Let's see. Yep, go ahead and pause and give this one a go. The answer will be up in 3, 2, 1. Okay, so here is the function rule. A couple things here. I've substituted in, I distributed 1/2 b. So 1/2 b times 2b. This is stuff that we were working on earlier in the year, is b squared. 1/2 b times 4 is 2b. If you don't understand that, sit down and work that out to try to make sense of it, because that's a really, really important part of this. And then over here, I just substitute 16 in for the b and simplify that out. I get an area of 288. That's it for today. Hopefully you got good notes. I'll see you in class.